sing a happy song together, and we'll all be a happy family.
Hi, welcome back to the channel. So we're looking at this little Grundig transformer that I think came from a radio cassette recorder, and I don't have any other information on it. And I tested the primary windings and found out there's just over 1k ohms between the grey and the black, and then this red lead, which I've put a sleeve over because that's not needed, is presumably 120 volt tapping in the middle. So yeah, that's what I've done there, and I've connected that into some cable I happen to have with the old red and black colouring, and I've put heat shrink over where I've soldered it on. Even though this is just a lash up to test it, always respect the mains. So yeah, I soldered them together and then covered them so that I'm not going to hopefully have any mishaps with that, even though I am going through an isolating transformer and a dim bulb system. This is all stuff that is no use anywhere else because the plug is an old one with no shield here on the pins, so it can't really be used for anything else, but I might as well use it as a lash up lead for doing things like this. And I've also connected the one output winding to my meter, which will be on, obviously, on AC volts, and we'll see what voltage we get. And this will just be off load initially, but we'll see what voltage we actually get across there. And what I'm using is also featured in my channel before. It's my homemade safety power supply for bench work, and what this comprises is this isolating transformer, and I've removed the earth connection here, so if ever I do need an isolated direct mains connection, I can use that plug. But also what I've done is taken the output from this isolation transformer, which is also across here, and it's gone straight to variac, and this scale is quite accurate for voltages, so it can go actually above 240 volts. You go up to about 265, something like that, but it is quite accurate. And I've marked off there when I was testing the American radio input, I was able to make sure I didn't go too far. Now, this has got a normal socket output, and like a lot of UK sockets, there's a switch with it as well. And there's a bulb in the socket here. That socket is in series with this and this, and there's a 2 amp fuse there, which is to protect this from damage. So that's the basic setup, and I can run this with different bulbs in there depending on what power I want, or I can put in this, which is a shorting plug. It goes in there, so I can operate this without a dim bulb as well if I want to. But that's featured in some of my other videos, so yeah, I'm using the same thing again here. So all I do is plug this in to the extension socket here, making sure first of all that we've got it on 0 and nothing's plugged in. So I'll just plug in the isolating transformer. That's now powered up. I ought to have a power indicator light. There's some modifications I like to make to this thing, So that will be perhaps another day for another video. So now we can plug in our test transformer to there, and at the moment this switch is off, this is turned down, so nothing's going to happen. We can turn on we are now on AC volts, obviously nothing there. Now the first thing we want to do is to put this switch on down here, and then we should be connected through, and as soon as I start to turn this, I should start to see some voltage up here. And indeed we do. Now that's only millivolts, not 133 volts. That's 133 millivolts, and we're putting in hardly anything. So we'll carefully ease it up. So if we put in, let's say, 20 volts, out here I'm getting around 800 millivolts out. And to get a rough estimate, I'm going to put in roughly 24 volts, which I think would be about there. This is very rough. I'm going to go by that scale. But we are getting nearly a volt out. Let's say we're getting a volt out at 24. We ought to get 10 volts out of 240, going by that. Maybe this is a 12 volt transformer. And if it is, that would be good for us, because that would be ideal for running the ECC 81 valve with its filaments in series. So I'm going to wind this up now. Being very careful in case there's a shorted turn or anything nasty happens here. We'll keep an eye on that. Nothing bad has happened yet, no magic smoke. Right, I'm now putting in about 100 volts. And we're not up to 4 volts yet, at 3.7. So let's go to 120. So that should be half of what we would expect to get, which might be a bit low for what we want. It looks like we might get 9 volts. Let's turn it on a bit higher. So nearly 170 volts here has given us about 6 volts out. So yes, we're going to be a bit lower than 12. And this is off load. So it may be possible we would use the ECC 81 with its filaments in parallel on load. That might drop it down to about the right voltage. .200 volts and 7 volts out. Of course we are on dim bulb, but there's no load on it really at all, so I don't think the bulb's going to make any difference. It's just protecting us from shorts. 220 volts gives us just over 7.5 volts. There's 230, 8 volts out, offload of course. So over here we are now putting in, that's 240. The bulb obviously not glowing, so we can ignore the effects of the bulb really. But yeah, it's 8.5 volts. So that's a tricky voltage really. Maybe we'll need to see what it will do with the valve on there, and whether it will cope with the load, and what the voltage drops to. Because when it's on load, it might be significantly lower. And I can, obviously if it's still too high, I can get around it by putting a dropper resistor in series. So I think we can use this to power the ECC81 with its filaments in parallel. Okay, so let's see how we get on. Okay, so now we have our valve ECC81 with the filaments connected in parallel. So that's pin 4 and 5 are linked together, and the other side is pin 9. So that's how we wired this up across the transformer with the meter across it, which will give us the reading. Now we should be able to go back and apply voltage to it on load. So I'm checking first of all that this is 0. Switch there is off. I'll plug in up here. The isolating transformer is now on, and the switch here is now on. Now we're going to be a bit more careful this time, because I hope this transformer will handle the load okay. If it's through a radio cassette, I think it will be okay, but we need to be a bit careful. Switch the voltmeter on. Right, obviously nothing at the moment, and we start to wind the voltage up just a little at first. Right, so we're putting in just about 10 volts, getting a few millivolts out. Would have been nice to monitor the current, but I haven't set that up. But presumably we are now taking some current. So we'll come up in voltage now carefully. So about 1.6 volts there, and only about 60 volts going in. So we should be about halfway. Well, we've got about 100 volts going in there now, and we're getting 3.1. So maybe a little bit high. We're aiming for 6.3 volts, really. So we'll come up slowly again. Right, hold there for a little while. 160 volts going in. So it looks like we're going to go over voltage, doesn't it? Not noticing any heat from the valve. I think it is slightly warming up now. There's the 6 volts going in, and unfortunately we're still under 200 volts going into the transformer. So it looks like we would need a dropping resistor. Yeah, the valve is getting warm, definitely. May not see it glow with the lights on in here. So when we get to 6.3, there we are, 6.3 volts. So that's the voltage the valve heater is designed to run at. And we are putting in 200 volts. So unfortunately we would definitely go over voltage. So it is going to need a dropping resistor if we use this transformer. But I'd like to let it run like that for a little bit and see if the transformer gets warm and if there's any other issues. I don't think we can actually see the valve heaters working, but it is actually feeling warm. You can just about see a glow there. I don't know if it shows up on the camera. We're on the way, but we do need to have a resistor in series. Okay, so now I've added 6.6 ohms, which should drop a couple of volts, and I had to use obviously separate resistors. I don't have very many higher wattage ones, but these are half watts, so that would handle 1.5 watts, which should be adequate. And we'll see what voltage we get across the valve with those. Let's just switch the meter on and bring it up a little way and see if we are connected all right. Yep, the voltage is coming up. We might get the blue smoke this time. Five volts. And we are not quite at 6 volts now. That's with 240 going in. So that resistor seems to be a bit too much. But we're getting close. I'm sure our valve will be getting warm. But the real question is, will the transformer be getting warm? I'm not going to touch it while it's got mains on it. I'm sure the resistors are nice and warm now as well. I mean, it probably would work at that voltage adequately. It's on the safe side. But the 2 volts was a guess, really. I probably only need to drop about 1.5 volts. Okay, we've tacked a 22 ohm across the 6.6. We should be in the region of about 5 ohms there now. So we'll see what happens with that. Switch to AC volts again. Plug our transformer in. And up we go. Right, so we're on 240 volts coming in. Look at that. And that was just a guess. Yeah, 6.3, spot on. with that lot in there, which should be about 5 ohms. So a 5 ohm resistor rated at about 3 watts would do the job. Could even use those. I don't think they'll overheat. So the thing now is to let it run for a bit and see if anything gets hot. But at this point, I think that's it for now. We've got a transformer with a resistor dropper and the ECC81 with its heaters at 6.3 volts. So I think we can move on to the next stage now by using this one. So that's it for now. Thanks for watching. We'll catch you on the next one. Bye for now.
Sing a happy song together, and we'll all be a happy family.